Hello and welcome to this lesson where we're going to update elements of our player HUD. We're going to want our progress bar to read the player health, so it updates and acts as a health bar. And we're also going to want to update our alien kill counter. Now, of course, we don't have any code or properties inside our marine blueprints yet that handles damaging the player or storing their kills. We'll get to this shortly, but first, let's focus on our widget. We've been working in the designer so far. However, in this lesson, we're going to switch over to this graph view. So while we can design widgets, widgets are also blueprints, so we can add code to them to drive their behavior. We're going to create a variable that is going to hold a reference to our marine blueprint. Let's hit new variable, let's call it marine, and let's change the variable type to our BP marine. So we're going to type in BP marine, we're going to get the BP marine here, and we're going to select object reference. Now let's hit compile. This reference isn't going to be set to the player's marine by default. We have to manually set this. We want to make it so when we create our widget, we set the value of this reference to be the player's marine. We create the widget inside the marine blueprint. In order to set the marine reference within our widget, we want to make it appear on this node as a pin. And this is going to be really easy to do. We can just select the variable and we can expose it. We can hit instance editable. We need this checked in order for us to hit expose on spawn. And it tells us when we hover over this, should this variable be exposed as a pin when spawning this blueprint. So if we check this and hit compile and come back to our marine blueprint, it doesn't look like anything's happened here, but if we right click on this node and we can hit refresh node, it now updates with a pin so we can set our marine reference. We can simply drag this out and we can type and search for self. So now when the game starts, we create our HUD widget and we set the marine reference to be the player's marine. And by having this reference to the marine blueprint in our widget is going to be able to read properties such as the player's health and how many kills they have. But we don't have these properties yet inside our marine blueprint, so I want you to go ahead and set these up. Inside the blueprints for your marine, create a float variable that we can use for the player's health. Then create an integer for storing the player's kills. So pause here quickly to set these up, and then once you've done this, come back and resume the lesson. Okay, so inside the marine blueprint, we should now have a float variable named health and an integer named kills. I've set the default value for the health to be 100 and the kills is set to 0. I've also put both of these inside a category named player properties. Now, how do we update our kill counter and our progress bar to read these values? Well, we're going to create a property binding. A property binding basically allows us to take things like our progress bar or our text and bind them to read the return value of a function or to read a value of a variable. If we select our progress bar, we can see just next to percent we have bind. We can drop this down and create a binding. So what does this do? Well, this creates a new function with a return value. Before we do anything, let's rename this function to getHealth. Let's make sure that we hit compile so we apply the name, and let's come back to the designer. We can see now that our progress bar is bound to a function named getHealth. So the progress bar is always going to update itself to match the return value of the getHealth function. And we can make this function return the player's health. We can get our marine, and we can get the health. And we can plug this straight in to the return value. So how do we know if this works? Well, if we come back to our marine blueprint, we can change the health to be 50. So the health bar should be half full. And we can see that it's still full. So why is this happening? Well, this is because of the value range of our progress bar. We can see that it only goes between 0 and 1. It doesn't go between 0 and 100. So we need to take the health from the marine here and divide it by a float. We can divide it by 100 to make it go between 0 and 1 instead of 0 and 100. So now if we come back to the level and hit play, we can see that the health bar is now half full. And just to confirm that this works, you can change the default value of the marine health and then play again to see that the progress bar is correctly matching the health variable. Awesome, so we've now bound the progress bar to read the player's health. Now, I want you to pause here and have a go at creating a binding for the kill counter so that it reads the amount of kills from the Marine blueprint. Okay, so to create a binding for the text counter, we're going to select the text that we want to bind the kills to. We're going to drop down bind next to where we set the text, and we're going to create a new binding. So this creates a new function that returns some text. And the text on the canvas is going to be bound to the return value of this function. So what we're going to do is make this function return the amount of kills of the Marine. So with the Marine, we're going to drag it out and type in get kills. And with the kills, we can simply drag and plug it straight into the return value, and it will convert the integer to a text value. And we can give this function a better name than what Unreal's given us. We can rename this to get kills as text. And now we can hit compile, and we can come back to the designer. Our text is bound to the return value of our function named getKills as text. And now we can come to our Marine, and we can change the default value of kills to something random just to make sure it works. We can put 408 as an example. So if I hit play now, my HUD should show that I have 408 kills, and it does. So this text is definitely reading our kills variable from our Marine blueprints. Let's just set this back to 0 because we don't want to start with 408 kills. Now I'm going to leave you with this final task of renaming the assets that we have in our player HUD. We can see that if we select any of them, Unreal has given them quite an ugly name. It says text block 105. So we can simply rename this to something like text block kill counter. So before moving on to the next lesson, I just want you to take some time to rename the elements of your player HUD. And that's the end of this lesson. In the next lesson, we're going to start setting up the aliens that are going to spawn and attack the player. So once you're ready, I'll see you in the next lesson. Hello and welcome to this lesson where we're going to start working on some AI that's going to chase down the player. Inside the characters folder in the content browser, we have this spider that we're going to make use of for our Martian aliens. So to get started, we're going to create a new character blueprint and assign this spider as the mesh. Inside our blueprints folder, we can create a new folder called AI. And within this AI folder, we're going to create a new blueprint class, and it's going to be a character. We're going to name it BP underscore alien. And we can double click on this to open it. And let's start by assigning the spider mesh to the mesh component. So we're going to drop down the skeletal mesh here and choose the spider. Now it may take a second for it to load for you, and you may have to compile shaders, but once it's done, you'll have this giant spider in your blueprints. Probably too big for us right now, so let's make it half the size. We can reduce it to 0.5 for the scale. And we can rotate it so it faces the forward-facing direction, the same as this arrow component here, and we can bring it down so its feet kind of are level with the bottom of the capsule. Okay, now you'll notice that the spider comes with its own animation set that you can find in the content browser. Now, I'm going to challenge you to set up an animation blueprint by yourself. Create an animation blueprint for your alien. In the anim graph, create a state machine that contains two states. The idle state, which will play the idle animation, and the walk state that will play the walk forward animation. Then in the event graph, calculate the AI's movement speed and store it as a variable, so that you can then set up the transition rules for your state machine by making use of the AI's movement speed. So pause here and take your time with this. Remember, you can always refer back to your Marine's animation blueprint to help you guide you through this if you get stuck. And then once you're ready, come back to the lesson and we can carry on. Okay, so I've created an animation blueprint for my alien, and I hope you have too. I'll just take you through my setup, but it's basically the exact same as what we did with our Marine's animation blueprint. In the events graph, on begin play, we store a reference to the alien. Then every frame, if the alien is valid, we calculate the movement speed and store it as a variable so we can access it inside the anim graph. And to calculate the movement speed of the alien, we get its velocity and call the vector length function, which will return its speed. Now inside the anim graph, we just have a state machine that contains the idle state that plays the idle animation and a walking state that just plays the walk forward animation. We enter the walking state from idle if the movement speed is above 0, and we enter the idle state from walking if the movement speed is equal to 0. So if we come back to our AI blueprint for the alien, we can come to the viewport and we can select the mesh component, we can drop down the anim class and assign our new animation blueprint to it. And we can see that it starts animating straight away. Awesome, so we're now ready to switch over to the event graph so we can start adding some blueprint code to make this alien chase the player. Take note that if you have a pawn that isn't possessed by a player when the game starts or when the pawn spawns, an AI controller will automatically be created and assigned to the pawn. This is why if we call any AI functions, the class will respond and navigate around the world. And this is what we're going to do right now. We're going to start setting up some AI for our alien. Inside the blueprints for our alien, we're going to right click and we're going to come to the AI category. Inside here, we can call the AI Move To node. And it says here, it's a simple order for pawns with AI controllers to move to a specific location. So we're going to use this node. We provide the pawn that's going to move, which is just going to be self. It's going to be this alien. And we can either provide a destination or a target actor that it moves to. We don't have to provide both. We can ignore destination if we have an actor that we want it to move to. We want it to move to our player character. So we can right click and just call get player character, and we can plug that straight in to the target actor. On begin play, we can simply get the AI to move to the player. Now we can hit compile and save. We can close the blueprint and let's drag an alien into the level. You'll notice that if you hit play, the AI doesn't move at all. This is because we need to provide a navigation mesh in our level. Navigation meshes are simply used to tell the AI where they can or cannot navigate in our levels. We're going to add a navigation mesh to our level now. To add a nav mesh to our level, we can look towards the modes panel. We have the volume section. If we scroll down on the volume section, we can find the nav mesh bounds volume. We can drag this out into our level and we can scale it up just like any other volume. We can press P to visualize how the nav mesh is perceiving our level. We can see that it's detecting our rocks, it's telling us that the AI can't walk there, and it's saying that the AI can walk around the rest of the level on the ground. And this is why the AI didn't work a moment ago. When we tried playing, we didn't have a nav mesh, so the AI didn't know where it could or couldn't walk. But now if we play the game, we can see that the AI is running directly towards us, but it's moving pretty quickly, and you'll notice that once the player exits the nav mesh volume, it will stop moving, and even if the player returns into the nav mesh, the AI is stuck again. And if we play again, and you'll notice that if the AI reaches the player, and if the player moves away, the AI will stop following them. So let's fix the AI speed and these issues we have here so the AI can continuously chase the player. Inside our alien blueprint, let's start with the movement speed. We can select our character movement component and we can change the max walk speed. I'm going to use a speed of around 375. Now the reason the AI stops moving if it reaches the player or if the player exits the nav mesh is because we only call the AI move to node once on begin play. Once the AI reaches the player, the on success output pin will execute, but it's not hooked up to anything, so the AI will stop. And the same goes for on fail, which will execute when the player exits the nav mesh. To make the AI continuously chase the player, we're going to drag out from the on success pin, and we're going to call a delay. We're also going to hook up the on fail output to the delay as well. So if the AI succeeds or fails to reach the player, we delay by 0.2 seconds, and then we can drag out from the completed output and call the move to again. So we just continuously execute our AI move to node. We can double click on the execution wire to add some reroute nodes as well, just to make this a bit more tidy. So on begin play, the AI moves to the player, and if they succeed or fail to reach the player, they will delay by 0.2 seconds and then try again. So now if we compile and save for the final time for this lesson and close this blueprint and hit play, we can see that the AI is moving slower and they're chasing the player. If the player moves out of the nav mesh now, we should see that the AI will stop at some point. There they go, so they're stopping because they can't reach the player, but as soon as the player re-enters the nav mesh, the AI will chase them again. And if the AI reaches the player again, and if the player moves away, we can see that the AI will still chase the player. So let's wrap up this lesson with a summary of the goals for our AI. We want the AI to chase the player, and they're already doing that, but also we want to make sure that the AI attacks the player when in range. The AI must cause damage to the player and eventually kill them, But the AI needs to receive damage as well when the player shoots them. The player should be able to damage them and eventually kill them. And the final step is to make our AI spawn in waves. So you now know how to add nav meshes to your level and how to get AI moving by calling the AI Move To node, which allows us to start tackling the rest of these goals over the next few lessons.